Okay, let's continue our analysis on market equilibrium. Basically, we started this three-step process to analyze changes in market equilibrium. So the first step is you want to understand whether there would be a change in demand or supply. And then you will want to figure out what is the direction, right? Whether the supply will increase or decrease, and whether the demand will increase or decrease. And then the third step is you would want to use the supply and demand diagram to see how equilibrium price and equilibrium quantity will change. And we finished the first example. It's an example in this ice cream market, right? So let me review this first example. So basically, we examine the following event. That is, the weather becomes very hot. And we know that if this is the case, then consumers' tastes will change, right? So basically, consumers will actually like ice creams more. So they will buy more ice cream. This implies that we will observe a change in the demand curve. And to be more specific, the demand curve will actually shift to the right, which represents the increase in demand. What's the third step? Well, the third step is about actually drawing out the demand curve and supply curve and see how equilibrium changes, right? So here we can see that as demand shifts to the right, we can see that the initial equilibrium will move to this new equilibrium, right? So this is how the equilibrium point moves. And we can see that the market will have a higher price and higher equilibrium quantity, right? So the equilibrium price increases by 50 cents and the equilibrium quantity increases by 3 units. Okay, now let's examine the second example. So let's say in the second example, a hurricane destroys part of the sugar cane crop and drives up the price of sugar. How does this event affect the market for ice cream? Now, let's repeat our three-step process. First, we can see that basically sugar is an input for ice cream. So if the price of input increases, then we should expect there is a change in the supply curve. So we know that supply curve changes. That's the first step. The second step, we could see that because input price is higher, so there should be a decrease in the supply, which implies supply curve should shift to the left. So that's the second step. For the third step, we have to resort to the supply and demand curve. So let's see how price and quantity changes, right? So you can see that this is the initial equilibrium, and we have an equilibrium price of $2 and equilibrium quantity of 7 units. And if the supply curve shifts to the left, the new equilibrium point will be here. And we can see that we will have a higher price at $2.5, and the equilibrium quantity will decrease by 3 units, right? So basically in this case, we could see that due to the decrease in supply curve, the equilibrium quantity will be lower and the equilibrium price will be higher. Okay, now let's see the third example. So the third example basically combines example 1 and 2. So we would consider the case when there are shifts in both supply and demand curves. Now suppose that the heat wave and the hurricane, they would happen during the same summer. And we want to analyze this combination of these two events. Now, first step, we want to think about whether demand curve and the supply curve will change. And according to example 1 and 2, we can see that in this case, both supply curve and demand curve will change. Basically, due to heat wave, supply curve will shift, and due to hurricane, basically due to the heat wave, demand curve will change, and due to the hurricane, supply curve will change. And then we can see that from example 1, because of the heat wave, the demand curve should shift to the right. And from example 2, because of the hurricane, the supply curve should shift to the left. Now, for the third step, we want to examine how equilibrium quantity and equilibrium price will change. So we would use this graph here, right? Let me use the graph in the lecture note because it's actually quite clear. So let's see. So this is the initial equilibrium point, right? And we know that the demand curve would shift to the right, and supply curve would shift to the left. So this gives us a new equilibrium point. And judging from this graph, we could see that quantity increases and price also increases. So it seems the answer is if heat wave and hurricane occur during the same summer, then both equilibrium quantity and equilibrium price should increase. So is this actually correct? Well, I would say this is only partially correct because we have to consider all cases, right? So you can see that this is just one case. The reason is because if you, let's say, in this case, the supply curve is at the position S2, right? So this is S2. If you compare the shifted distance of demand curve versus the shifted distance of the supply curve, you can see that the demand curve has shifted a lot, and there is only a very small shift in the supply curve. So this is precisely the reason why we could see an increase in quantity and an increase in price. Now let's see a different case. Let's say if we have a much larger shift in the supply curve, let's see what will happen, right? Let's say supply curve shifts to the left, but to a much larger difference. Let's call this new supply curve at S3. Obviously, this would be the new equilibrium point. What you can see here, you can see that still you're getting higher price, but you're getting slightly smaller equilibrium quantity, right? So you can see that for this specific example, you could only be certain that price will increase, and you're not certain how equilibrium quantity will change. So let me first use the lecture note to talk about all three cases. So this is the case, right, we just talked about. That is, there is a small change in the supply curve and there is a large change in the demand curve. So the result is price rise and quantity rises. And then this is the case when we observe a small change in demand curve, but there is a large shift in the supply curve. In this case, we could see that price rises and quantity falls. And if you look at this third case, which is a very special case, you can see that the shift distance in the demand curves and in the supply curves, they're the same, right? So in this case, you can see that price rises, but quantity remains the same. So basically, this tells you that when you're analyzing how market equilibrium and the market price changes, if both curves, that is, if both demand and the supply changes, you have to be careful because it's possible that there is only one thing which is certain, but the other thing would be uncertain. In this example, you're certain that price will increase, but you're uncertain how quantity will change, right? Now let's see why you're getting this kind of result, right? So let's go back to our analysis here. So we know that So we know that due to heat wave, right? Due to heat wave, demand will actually increase. So let me write it here. So heat wave tells us demand increases, and hurricane tells us supply decreases. And we know that if demand increases, equilibrium quantity definitely increases, and equilibrium price definitely increases. And if supply decreases, we know that equilibrium quantity decreases and price increases. And in the example 3, we have to combine these two events. We have to combine the change in the demand curve and the change in the supply curve, right? Now you can see that if you combine these two events, then it's obvious, right? Because under both events, equilibrium price will increase. So the combined effect is the price will increase, right? So it's certain price will increase. Now what about the equilibrium quantity? Well, you can see that when you're combining these two events, their effect on the equilibrium quantity, they are to the different directions, right? So you're really not sure how this equilibrium quantity will change when you combine these two events. Essentially, you can see that if the effect of a heat wave is more important, right? So if the heat wave dominates, in this case, you can see that quantity should increase. So if the effect of hurricane dominates, right, then quantity should decrease. And if the effect of heat wave equals the effect of hurricane, then Q should stays the same, right? Q should the same. Right? So this explains why you would get 3 different cases depending on how large you can get in the changes of supply versus in the changes of demand, right? Okay, now let's see this table. This table basically gives you the summarization how market equilibrium will change if there is a change in supply and if there is a change in demand. So one thing you can see here is if there is only one change, that is, let's say if demand keeps the same and if only supply changes, right? If only supply changes, then you can be certain how market price and market quantity will change. Similarly, Similarly, if no change in supply and only demand changes, then you will be certain how price and quantity will change, right? So basically, these outer cases, that is, these cases, they are easier ones, right? You could be certain how market price and market quantity will change. However, for these four cases, they're more complicated, right? Because for these four cases, both demand and supply change. And you can see that there is always one thing which is uncertain, right? So you can see that for example, if there is an increase in demand, there is an increase in supply, the price is uncertain. And if there is an increase in demand and there is a decrease in supply, quantity is uncertain, right? So you gotta be careful that you would know that if both demand and supply changes, then there is always either quantity or price which is uncertain, right? So you have to be careful with this. And my recommendation is you don't really need to memorize this table, right? You should be able to draw out demand curve and the supply curve and see how the changes in the curves will affect the market equilibrium. And then you should examine how market price and market quantity should change because of changes in supply and demand. Okay, let's see this quick quiz here. On the diagram, show what happens to the market for pizza if the price of tomatoes falls and the price of hamburger increases. Okay, first let's think about the three-step process, right? So here you can see that the price of tomato falls. Remember, tomato is an input for pizza. So this should affect the supply curve for pizza, right? And the price of hamburgers increases. We know that hamburger is a substitute for pizza. So you can see that this should affect pizza's demand curve. So this finishes the first step. We know that both supply curve and demand curve should change. Now the second step. Okay, first let me write down the first step. We know that both demand and supply will change. Second step, we want to understand how or what is the direction, right? How the demand curve and the supply curve will change. So if price of tomatoes falls, then this implies input price is lower. So this should shift supply curve to the right, which means supply should increase, right? And then we also have the case that price of hamburgers increases. So in this case, if hamburger becomes more expensive, then people will be more willing to buy pizza, right? So in this case, you can see that demand for pizza should also increase. And now the third step is we would combine these two changes, right? So we have quantity here and price here. Now let's say this is the initial price, D and S. And now we have the shift of curve. So let's see, we have, okay, so demand will increase. So this is the new demand curve. And we also know that supply will increase. So this is the new supply curve. So basically the equilibrium point will move from here to here, right? And now you have to be careful in stating which or whether price or quantity is certain, right? So here you can see that you're certain that quantity should increase. but you're not certain how the market price should change, because you can see that in the case, or in this graph, you can see that market price is almost the same. However, you can see that if I redraw this supply curve, let's say if the supply curve increases a lot, right? You can see that the equilibrium price will be lower. Or let me continue manipulate the supply curve. Or if the supply curve only increases a little bit, so let's say this is the new supply curve, and this is the new equilibrium point, and then you can see that the market price will actually be higher, right? So in the end, you're really uncertain how market price will change. Okay. Okay, now let's talk about the content in the textbook appendix, the mathematics of supply and demand. I would say it's slightly harder because you have to solve equations. You have to know how to actually calculate a number for the market price and for the equilibrium quantity. And so first, let me go through these steps, and hopefully you could know how to solve the equation here. So basically you can see that this is what we got from the textbook, right? So we have the equilibrium price at $2 and equilibrium quantity at 7. Now the question is, how do you get these numbers, right? How do you get these numbers? Right? That's our question here. That is, we want to understand how to solve equilibrium price and equilibrium quantity. So let's start the demand curve. So let's assume demand curve is given by a function, or is given by a equation. Okay. So this QD here is quantity demanded, and P here is the market price. So this basically tells you that if price is 0, quantity demanded is 20. If price is 10, then quantity demanded is 0. If price is 5, then quantity demanded is 10. You can see that as price increases, quantity demanded decreases. So this is actually a demand curve, right? And let's see the other side of the market, that is the supply curve. So supply curve is given by this formula, right? QS is the quantity supplied and P is the market price. So you could also plug in some numbers and examine this is actually a supply curve. Let's say if P is 0, then we get QS, which is minus 10. If P, okay, let me use larger price because I don't want to have negative quantity supplied. So let's say if P is 5, so we have QS, which is 10 here. And if P is 10, then QS here is 30. If P is 15, then QS is 50, right? So you can see that as price increases, quantity supplied increases. So this is actually a supply curve. You could also draw out these curves. So let's see how could you draw out these curves, right? So we put Q here and P on the vertical axis. So we know that if P is 0, Q is 20, right? when P is 0, Q is 20. So we have this point. And if P is 5, then Q is 10. So this gives us this point. And if P is 10, then Q is 0. So this gives us this point. So basically you can see that if we connect these three dots, we would have a straight line, which is the linear demand curve given by this equation. Right? Similarly, you could also draw out the supply curve. So quantity, price, 10, 20, 30, 40, 50. And this is 5, 10, 15. And we know that if P is 5, then quantity is 10. If P is 10, then quantity is 30. And if price is 15, then quantity is 50, right? So this gives us a supply curve looks like this. Okay, now we have these two equations. The first equation gives us demand curve. The second equation gives us the supply curve. So our question is, how do we solve the equilibrium? Here the question, how to solve the equilibrium, means how could we find out the equilibrium price and the equilibrium quantity, right? So what we will do is we will solve this market equilibrium according to the definition of equilibrium, right? What is the definition of equilibrium? Well, we know that if a market is in equilibrium, then quantity demanded equals quantity supplied, right? So this implies if the market is in equilibrium, QD equals QS. This tells us 20 minus 2P equals minus 10 plus 4P. So you can see that this is the equation which helps us to solve market price, right? Now, how should we solve the market price? Well, you would want to move this minus 2P to the left-hand side to the right-hand side. So this becomes 20 equals minus 10 plus 4P. Remember that we're having minus 2P on the left-hand side. And when you're moving a term from the left-hand side to the right-hand side, you have to change the sign. So minus 2P becomes plus 2P or positive 2P. Next, we move the minus 10 from the right-hand side to the left-hand side. Again, you have to change the sign. So it becomes 20 plus 10 equals 4P plus 2P. And what is 20 plus 10? It's just 30, right? What is 4P plus 2P? It's just 6P. So if 30 equals 6P, then we could solve P equals 5, which is essentially 30 divided by 6, right? So we know that market price is 5, right? This is the answer here. Now, what is the market quantity or equilibrium quantity? Well, we could just use either demand curve or supply curve. Both curves will give you the correct answer on equilibrium quantity. So here QD equals so here QD equals 20 minus 2 times 5, which is 10 here. And you can verify that using supply curve gives you the same answer, right? So minus 10 plus 4 times 5. Again, it gives you 10. So we know that the market equilibrium price is 5 and the market equilibrium quantity is 10. Okay, that's how you solve market equilibrium. Now let's examine how could we calculate shortage and surplus. So we know that equilibrium price is 5. So let's say the price is 4, which is smaller than 5. We know that if market price drops below equilibrium price, there will be shortage, right? So let's verify there will be some shortage. So quantity demanded equals 20 minus 2 times market price, which is 12. And QS is minus 10 plus 4 times 4, which is 6. So you can see that QD is larger than QS, right? So in this case, because quantity demanded is larger than quantity supplied, we can see that there is shortage. And similarly, we could examine the case of surplus. We know that if market price is above the equilibrium price, then there will be surplus. So let's examine the special case of price equals 6, which is larger than 5. So we are expecting surplus here. Now, if price is 6, then quantity demanded, so quantity demanded is given by 20 minus 2 times the price, which is 8. And quantity supplied, which is minus 10 plus 4 times 6, which is 14. So obviously it's larger than 8. So quantity supplied is larger than quantity demanded. So we are getting surplus here, right? Okay, that's for chapter 4. So now let's talk about the true-false problems. Okay. So the first one says, in a perfectly competitive market, buyers and sellers are price setters. So for this one, you can see that it is not correct, because in a perfect competitive market, buyers and sellers are price takers, right? So this statement is incorrect. Second, if the demand for a good falls when income falls, this good is called an inferior good. This is incorrect, because by the definition, right? If it's an inferior good, then the demand for the good should increases when income falls. So essentially, if the demand for a good falls when income falls, this good is a normal good. The third one, when an increase in the price of one good lowers the demand for another good, the two goods are called complements. Now, if you examine the definition from the lecture note, you can see that this one is actually correct. This one is the definition for complements. Okay, let's see the fourth problem. An increase in the price of pizza will shift the demand curve for pizza to the left. This is incorrect, because we're talking about the change in the price, which means we should observe a movement along the curve, right? So there will be no shift in the demand curve. Fifth, a reduction in the price of a product and an increase in the number of buyers in the market affect the demand curve in the same general way. So let's see whether this is correct. First, a reduction in the price of a product means we should observe movement along the curve. And then an increase in the number of buyers in the market means we should observe the demand curve shift to the right. That is, the demand should increase. So you can see that this statement is not correct. Okay, sixth. If a firm making frozen orange juice expects the price of their product to be higher next month, they will supply more to the market this month. So this is about producers' expectation. You can see that this is incorrect because if a firm expects its product will be more expensive next month, they should reduce their supply to the market this month because they want to potentially hoard some orange juice. Then they could sell the orange juice in the next month in a higher price. Seventh, if there is an improvement in the technology of producing a product, the supply curve for that product will shift to the left. So basically now we're talking about the advancement of technology. We know that if technology becomes better, then there will be an increase in the supply, right? So if there is an increase in the supply, then the supply curve should shift to the right. So this is not correct. Eighth, a movement along a supply curve is called a change in supply, while a shift of the curve is called a change in quantity supply. This is not correct because a movement along a supply curve is called a change in quantity supplied, and a shift of the curve is called a change in supply. Okay, ninth problem. A reduction in an input price will cause a change in quantity supplied, but not a change in supply. Well, this is obviously wrong because a reduction in input price should cause a change in supply, and then the change in supply will cause a change in quantity supplied. Okay, let me draw this out. So let's say we have this supply curve and demand curve. So if there is a reduction in the input price, you can see that what first happens is we will observe that the supply curve shift to the right, and we will have a new equilibrium point. And we could also see that the quantity supplied will change. That is, the quantity supplied will increase, right, due to the change in the supply curve. Okay, the 10th question. Surpluses drive price up, while shortages drive price down. Well, this is not right because you can actually, first you could go back to the lecture note. You can see that if there is surplus, then it means that the quantity supplied is larger compared with quantity demanded. In this case, surplus will actually drive price down. And if there is shortage, meaning that a lot of buyers will want to buy this product, so naturally this will actually push the price up. Okay, 11th. A shortage will occur at any price below equilibrium price, and a surplus will occur at any price above equilibrium price. This is actually correct. So, you could basically look at the supply and the demand curve, right? And let's say this is the equilibrium price, right? So this is, let's call this as PE, which represents equilibrium price. So if there is a price which is below the equilibrium price. Let's say we're looking at this price here. And immediately you can see that quantity demanded, which is this, is larger than quantity supplied. So you will see a shortage, right? So you will see a shortage here. And if a price is higher than the equilibrium price, you will see quantity supplied is larger than the quantity demanded. So you will see a surplus. Okay, 12. In a market, the price of any good adjusts until quantity demanded equals quantity supplied. This is actually correct. This is exactly how market reaches its equilibrium, right? And we talk about this in the lecture note. So basically, you can look at, again, this picture here. Let's say we're having surplus, right? If we have surplus, then suppliers have to compete for buyers. So they would have the incentive to reduce the price. So the market price will drop to the equilibrium price. We could also think about shortage, right? So if there is shortage, then you can see that buyers, they're competing for a certain product. In this case, they will actually beat up the market price. So in this case, market price will increase, right, to the equilibrium price level. Okay, now let's see problem 13. The behavior of buyers and sellers drives markets toward equilibrium. Well, this is right. We just talked about this, right? Okay, 14th. It is not possible for demand and supply to shift at the same time. Well, this is obviously wrong. We have talked about this in the lecture note, and we actually did two practices to examine how market equilibrium will change when both supply curve and demand curve change. And again, let me remind you that if both supply curve and demand curve change, then there is always one thing which is uncertain. It's either price uncertain or quantity uncertain. So you have to be careful when you're answering your question, right? Okay. You can see that you have the answer here. Of course, I have given you the answer on this page. So you could think about these problems yourself and compare your answer to the correct answers. Okay, now let's move on to chapter 5. Okay, let me look for chapter 5 in my folder. Okay, I think this is chapter 5. Okay, so in chapter 5, we talk about elasticity of supply curve and demand curve. And we will talk about some applications by using elasticity. So why do we want to talk about elasticity? So let's imagine a case that the price of gas is higher in Canada, right? Now, if you want to think about the following question, you could ask, how Canadian consumers respond to higher gas price? Well, obviously, you would answer that, well, gas price is higher. I'm pretty sure that consumers will buy less gas and drive less, right? However, you could be more precise, right? Because you really don't know how much less, right? So you want to understand the quantity here. That is, how much less Canadian consumers will reduce their consumption of gas if the price of gas increases by a certain amount. So to get a precise answer, to get a precise understanding how quantity demanded respond to price changes, we need the definition, the concept of elasticity. So let's say we have some precise answer, right? After some measurement, we find out the consumption of gas would fall by 2% if price increases by 1%. This is a very precise answer. And later you will see that to get this kind of answer, right? To get this kind of answer, you need the definition of elasticity. Okay, now we could officially define the price elasticity of demand. You could also use the short name, which is PED. Now, how do you define price elasticity of demand? Well, it is really defined by this very simple formula. So price elasticity of demand equals the percentage change in quantity demanded divided by the percentage change in price. So let's see this example here. Let's say there is a 10% increase in the ice cream price. And you observe that after this 10% increase, the amount of ice cream you buy falls by 20%. So what's the price elasticity here? So it's the change or the percentage change in quantity, that is 20%, divided by the percentage change in price, that is the 10%. So the price elasticity of demand is 2, right? So it basically means that the change in quantity demanded is actually twice as large as the change in the price in the percentage terms, right? Another convention about calculating price elasticity is about the sign of price elasticity. At least in this book, we would always want to use a positive number for the price elasticity. Well, because if you think about this carefully, it seems that you should use a negative number. If you look at this statement here, it says 10% increase, right? So basically we should put a positive 10% here. And we have this fall by 20%, right? So we should use minus 20%. So this will give us a negative 2 here. However, as I said, in this textbook, in this lecture, in this class, we would follow the convention. We would drop the minus sign and we will just use a positive number. So we would drop the minus sign and we would use the positive number. Okay. It seems that calculating the price elasticity is very simple, right? It is very straightforward. However, at least in introductory courses, it is not that simple, because you can see that you would actually get some confusions depending on what is your starting point, right? So basically, let's say you have 2 points. You have point A and point 2 on the demand curve, right? What I'm talking about is, if this is your demand curve, you could have a point A here and point B here. Let's say you want to calculate the price elasticity from point A to point B. Or you could calculate the price elasticity from point B to point A. Ideally, you should get the same number because you're on the same demand curve. However, you will see that depending on what is your starting point, you will actually have different numbers. So let's see the following example. Okay, now let's say if we have 2 points, right? let me follow the lecture note. So point A here, point B here. So let's say at point A, the price is 4 and the quantity is 120. At price B, the price is 6 and quantity demanded is 80. Right? And now let's calculate the price elasticity. Right? So let's calculate the price elasticity from A to B. Right? How do you do the calculation here? Well, first you have to find out the percentage change in quantity and the percentage change in price, right? Then you will calculate the division. So the percentage change in quantity is equal to remember we are starting from A to B. So the initial quantity is 120. And at point B, we have quantity 80 here. Right, so this gives us minus 33%. Now what's the percentage change in price? Well, at point A, the price is 4. And at point B, the price is 6. So this gives us 50%. And you can see that this PED from A to B is given by minus 33% divided by 50%, right? Which is 0.66. Now let's look at the other case. So the other case. So PED from B to A, right? Again, let's calculate the change in the quantity here. So the percentage change in the quantity here, remember now you're starting from 80, right? So it's 80 and later you get 120. So this gives you, I think it's 50%. And what's the change in the price? Well, you start from 6 and you would end up with 4. So this is, I think it's minus 33%. So here the price elasticity from B to A is equal to 50% divided by 33%, which gives you 1.5, right? 1.5. So now you can see that we have this conflicting result, right? Depending on what's the starting point, you will get different price elasticity. In the first case, when A serves as the starting point, PED is 0.66. And in the second case, when point B serves as the starting point, the price elasticity is 1.5, right? Why do you get different numbers? Well, it's really because if you start from point A, then you would use A as the base when you're calculating the percentage change. And if you're starting from point B, you would use point B as the base when you're calculating percentage changes. So if you have a different base in calculating changes, then you will get different numbers. Now, how do we solve this problem, right? How do we solve this? Well, we will use the middle point method, right? What is the middle point method? Well, if you look at the calculation here, let's say we're looking at this part, right? We're looking at these parts. These are bases you're using when you're calculating percentage changes. So instead of using 120 as the base, we would like to use the middle point between 80 and 120. So what's the middle point between 80 and 120? Well, it's 80 plus, oops. So the middle point here is 80 plus 120 divided by 2, which is 100. So in this case, right, we could redo the calculation here. So we would use 100 as the base. In this case, we have minus 40, I think. Minus 40%. Similarly, we don't want to use this number 4 as the base. We would like to use the middle point. What's the middle point? Well, it's 5, right? Because the middle point between 6 and 4 is 5. Right? So it's 5. Now we would use 5 in the denominator. So this gives us 40%. Yes, this gives us 40%. So if we are using middle point method, we can see that the PD from A to B is 1. Now let's try to calculate the elasticity from B to A, right? Again, we will change these denominators and we will use we will use the middle point. So the middle point here is 100 and the middle point here is 5. And then we can see that we will get 40% and minus 40%. So again, the PD from B to A is 1, right? So this is great. Now you can see that no matter what's your starting point, you will always get the same answer on the elasticity, right? Okay, let's summarize. So basically, in the middle point method, what changes are the denominators, right? You can see that when you're doing the calculation, in the denominator, in calculating both the percentage change in quantity and the percentage change in price, you will always want to use the middle point, where the middle point is defined by average, right? So let's say if you have two quantities, Q1 and Q2, the middle point is given by Q1 plus Q2 divided by 2. Similarly, if you have two prices, P2 and P1, then the middle point is given by P2 plus P1 divided by 2, right? Okay, so this is the middle point method. It's actually pretty simple. For the purpose of homework or exam, what you need to do is you need to memorize this formula, right? And you need to be able to plug in the correct number. Okay, so we could basically calculate the elasticity, right? And depending on the number of the elasticity, we could have three different kinds of demand curve. The first one is if the elasticity is larger than 1, then we say the demand is elastic, because in this case you can see that quantity demanded moves proportionally larger than the price. And if the elasticity is less than 1, then we would say that the demand is inelastic, because in this case, quantity moves proportionally less compared with the price. So in the special case that when the elasticity is exactly 1, then we would say that the demand curve has unit elasticity. In this case, quantity moves the same amount proportionally as price. Okay, let's look at the example, which gives you several pictures, and we could um, do some calculation, learn how to calculate the price elasticity of demand. So let's see the first one. The first one is a perfectly inelastic demand, and it says elasticity is 0. So let's see whether this is the case. So let's pick 2 points, and we could see that price elasticity equals the percentage change of quantity divided by the percentage change in price. But you can see here, the quantity stays at 100. So the numerator is always 0, right? So 0 divided by the percentage change in price. This gives us 0. So the price elasticity of demand for the first graph is 0. Now let's see the second one. So again, we pick 2 points. So let's see what is the PED here. So PED here is first the percentage change in the quantity, right? So we have 100 minus 90 divided by the middle point. The middle point is 95. And price, so 5 minus 4 divided by the middle point, which is 4.5. This gives us 0.5. Okay, now let's see the third one. So for the third one, PED is 20 divided by 90. 1 divided by 4.5, which gives us 1. For this one, we have PED equals 50 divided by 75, and 1 divided by 4.5, which is 3. Okay, the last one. So this one is the percentage change in quantity divided by the percentage in price. But you can see that when you're having a horizontal demand curve, the price stays at 4, which means the percentage change in price is always 0. So if you use a number, right, if the number is divided by 0, you will get infinity. Right? Okay, so we have finished calculating 5 different elasticities for different pictures. Now let's see what kind of lessons we can get here. Now, if you relate elasticity to the slope of the demand curve, you will actually observe a certain pattern here. First, you can see that for the first picture, what you can see here is it's vertical, right? And you get a 0 elasticity. And now let's see graph B. So you can see that the demand curve is still quite steep, and you get 0.5 elasticity. And now if you look at graph C, you can see that the demand curve is actually flatter compared with graph B, and we're having a larger elasticity. Now if we move on to graph D, you can see that the demand curve is even flatter, and we're having an even larger elasticity. And then if we continue to the last case, you can see that the demand curve becomes horizontal, and the elasticity becomes an infinity, right? So what does this tell you? It basically tells you this. I'll write it here. So what's the lesson here, right? the lesson here is steeper demand curve has smaller elasticity. Or you could say flatter demand curve is more elastic, right? Okay, that's the lesson here. I hope you could remember this lesson because it's actually quite useful when you're solving problems. And here you can see that we have several, or we have some elasticities for different kinds of demand curves, right? From eggs to Mountain Dew. And you can see that the elasticities can have a very small number, which is 0.1 for eggs. And then it could becomes large. In this case, we have 4.4 for Mountain Dew. Now, you might wonder, right? Why do we see these differences in elasticities for different kinds of consumption goods? And you might wonder what affect elasticity, right? So let's see, let's learn about several factors which could affect elasticity. So the first factor is about the availability of close substitutes. So basically you can imagine that the demand curve will be very elastic if this product has a lot of close substitutes, right? Just think about several examples. You could think about butter and this man-made butter, which is called margarine, right? So in this case, you can imagine that if butter and margarine are close substitutes, and you can imagine that if there is a small increase in butter price, then a lot of consumers, they will just flock, they will just instead choose to buy butter. Oops, sorry. Let me restart. So if there is a small increase in butter price, then you should imagine that a lot of consumers, they will actually instead choose to buy margarine, right? In this case, the demand of the butter will actually suffer a lot. So in this case, you can imagine that the demand for butter is actually very elastic because margarine can serve as a close substitute. We could also talk about eggs, and we have seen that eggs have a very small elasticity of 0.1. So why this is the case? Well, because you don't really have a close substitute for eggs, right? At least for me, I cannot think about a close substitute. So in this case, you can imagine that even the price of eggs change, your consumption will only change maybe a little bit. In this case, you can imagine the elasticity for eggs will be small. Okay, the second, necessities versus luxuries. So generally, necessities will have inelastic demand, and luxuries will have elastic demand. Just to think about it, food is a necessity, right? So even if the price of food changes, most likely your consumption of food will almost stay the same, right? So in this case, the elasticity for food is small. Now think about some luxury items, right? Think about a fancy meal at a high-end restaurant. You can imagine that if the price increases a lot, maybe you just won't go there anymore. So in this case, the elasticity for the demand for fancy meals is very elastic. Okay, let's talk about the third factor. The third factor is about the definition of the market. Generally, if the definition of the market is narrower, then the elasticity for that market demand will be larger, right? So let's go from food to chicken meat, to fried chicken meat. So you can see that market for food is a very widely defined market, and we have discussed about this. It's very inelastic because no matter what is the price of food, you still have to eat, right? And now think about the market for chicken meat. So compared with the market for food, the market for chicken meat is narrower, right? And in this case, you can imagine that it's a little bit of more elastic compared with the market for food, because if the price of chicken increases, you could potentially find other meat alternatives, right? Maybe you could buy more pork, or you could buy more fish, or you could buy more beef. Now think about the market for fried chicken. It's a even narrower definition, right? In this case, you can imagine that the elasticity for this market should be quite large. The reason is because, well, if the fried chicken becomes more expensive, maybe you could buy, I don't know, fried duck, fried beef, right? So in this case, you can see that the definition, or how narrow the market is defined, determines how elastic the market is. Okay, the fourth factor is about time horizon. This one is actually quite easy to understand. Generally, demand is more elastic over longer time horizon. This is easy to understand because you can imagine that for demand curve to be elastic, consumers, they have to change their quantity demanded, right? And if you give a consumer longer time, then the change in consumption pattern, the change in quantity demanded will naturally be larger. So just think about the following case. Let's say the gas price increases. And you can imagine that initially, the quantity demanded for gas should fall, right? More specifically, because you're still having a car, you're still driving your car, then in the short term, potentially, the gas consumption will only fall a little bit in the first several months. But you could imagine that in the long run, right, you could potentially sell your car. Instead, you could take a bus. In this case, you can see that the demand for gas will actually fall further, right? So this implies as time goes, if we are looking at a longer time horizon, the elasticity for demand should be larger, right? Simply because consumers, they need longer time to make adjustments in their consumption patterns. Okay, that's for today's class.